students, as I told you that I'll be sending in sums of surface tension. Okay, so today we'll be doing sums of surface tension. So before we start the chapter, I would request you all to please open page 658 of your Nootan physics book. Okay, there you will get the numericals of surface tension. Now in the beginning of the sums, students, if you see some table is given over there where values of surface tension of some substances are given, because when we go through the sum you will see that some surface tension values they have not given. Those values you can get it from the table which is given over there. Okay, so before we start the sums, as I always do, let's recap with the formulas. So the first formula, surface tension is force by length. Okay, F is equal to 2L into T. T, surface tension which is related with work done. So T is equal to W by delta A, where W is the work done and delta A is the increase in the surface area. Okay. Now remember the area, in case when I am talking about area, remember a soap bubble or air bubble or whatever bubble, it is spherical in shape. Okay, so the surface area which we are going to take over here is 4 pi r square. Okay, now T, which is the case of surface tension in case of capillary rise, T is equal to R radius, H height, rho density, G acceleration due to gravity by 2 cos theta. Theta is the angle formed. Okay. Again HR we have getting from this formula only. This is another deduction. HR is equal to 2T by rho G. Okay. Now H dash is equal to H by cos theta. What is H dash? Means suppose we are talking about capillarity and we have taken two different liquids. Okay. In that case the one height is H dash, another is H. And theta is the angle formed between them. Okay. P, that is the excess pressure. In case of air bubble, it is 2T by R. And excess pressure in case of soap bubble, it is 4T by R. One more formula which is inside, like pressure, like any bubble, there is a pressure outside also and inside also. So the inside pressure is nothing but outside pressure plus the excess pressure. Okay. So let's get started with the sums. So let's see what the first sum is telling us. It is told how much work is done. That means obviously you have to find out W. In enlarging the area of a soap bubble by 1 centimeter square. That means delta A is given as 1 centimeter square. Now as I always told you, centimeter square is not the proper unit, so we'll convert into meter square. So you know that 1 centimeter is 10 to the power minus 2 meter. Okay, so square it is there, so it will be 10 to the power minus 4 meter square. Okay, now in this case let me tell you that soap bubble, here they have told soap bubble, they have mentioned soap bubble. So soap bubble basically it has two surface areas. Okay, so in this case our area delta A, it will be nothing but 2 into 10 to the power minus 4 meter square. Remember in case of surface, here also when I talked about excess pressure, it is in air bubble it is 2T by R, and in case of soap bubble it is 4T by R. That means there are two parts, sides of the soap bubble. Okay, so here we will be using delta A as 2 into 10 to the power minus 4 because soap bubble has two areas. Okay, so we have got the area, tension. I have got the value of tension from the beginning, from the that table which is given in the beginning of the numericals. Okay, so please see the value from there. Okay, so surface tension is given as 3 into 10 to the power minus 2 Newton per meter. Okay, so we can see here formula T is equal to W by delta A. Okay, so what will W be equal to? Just cross multiply. So it is T into delta A. Okay, T you know, delta you have got it. Just put it, solve it and get the answer. This is a very easy sum. Okay, so students, please don't forget that soap bubble, okay, it has always two areas. Okay, so whatever the area is given delta A, you have to multiply it with 2 to get the proper area. Okay, now let's move to the next sum, sum number 2. Let's see what sum number 2 is telling us. Okay, sum number 2 tells us how much work. Again here W you have to find out. In making a soap bubble of diameter 2 centimeter. So you see here student, diameter is given as 2 centimeter. So we don't need diameter, we need radius. So what will be the radius? 2 by 2, because radius is nothing but diameter by 2. So radius will be 1 centimeter. 1 centimeter is how much meter? 0.1 meter. Okay. Now what we have to find out? We have to find out the area. What did I tell you? Delta A. Now, delta A student, you have to remember that your area, soap bubble, I told you that in case of soap bubble, it has two surface areas, okay? So, here it will be 2 into 4 pi r square, okay? So, what is, so 2 into 4 into 3.14 pi and r square is, as you can see, it is 0.01 whole square. Okay, so if you solve it, you'll get delta A. Okay, you're getting delta A. Now, what else is given over here? Okay, so nothing else is given. So, W you have to find out. So, what is formula of W? Just now we have got W is nothing but delta A into surface tension. Again, I'm telling you students, surface tension value is not given. But as they have mentioned the soap bubble, so you're going to take the surface tension value of soap bubble as 3 into 10 to the power -2 Newton per meter. So, you know tension, you know your from here you're getting delta A. Just put these values, solve and get the answer. Okay. And please don't forget to write the unit of work done as joules. Okay. So, this is sum number 2. So, just these things you have to remember student that in case of soap bubble has two surface areas. So, whatever the area is given, please multiply it with 2 to get the proper surface area of soap bubble. Okay. Now, let's move to sum number 3. Let's see what sum number 3 is telling us. So, as I always tell you students, please when you're going through the sums, okay, read the sum and keep on writing the quantities. So, so what will happen? You will never miss track of what you're doing. So, please keep on writing down the quantity. Number 3. In increasing the area of a film of soap solution, again soap solution, from 50 centimeter square to 100 centimeter. That means initial area is given as 50 centimeter square and final area is given as 100 centimeter square. Okay. So, what will be delta A? It is nothing but final area minus initial area. Okay. Because anything, change of anything means final minus the initial. Okay. So, it is 100 minus 50. That is 50 centimeter square. Coming to it. Okay. Next. Then it's given 3 into 10 to the power -4 joules of work is done. Here W is given as how much? 3 into 10 to the power -4 joules. Now, here one thing, delta A we have got as 50 centimeters square. Okay, but as they have mentioned here soap solution and soap solution or soap bubble, as I told you, it has two surface area. So, we'll be multiplying this with 2. That means 100 centimeters square, which is nothing but just divided by 1 with 4 zeros to get converted into meter square. Okay. So, we get it as 1 by, that means 0.01 meter square. Okay. Or you can write 10 to the power -2 meter square also. Both are same. Okay. So, work done is given. What you have to find out? Calculate the value of surface tension. So, very easy. Just put it in the formula. T is equal to W by delta A. So, what is delta A? Delta A is equal to 0.01 meter square. What is W? 3 into 10 to the power -4 joules. So, you know W, you know delta A. Put it, solve and get the answer. So, very easy sum. Okay. Now, let's move to sum number 4. So, these are students basically just go through the sums and just direct formula applications. Okay, these are just a direct formula application. You know the formula, you can easily do the sums. Okay. Next, number 4. Let's do sum number 4. It's given surface area of a soap bubble. Again, surface area of a soap bubble is given as 2 into 10 to the power 3 meter square. So, to find out delta A, obviously, we have to multiply. They have given you the surface area, but since it is soap bubble, we are going to multiply it by 2. That means 2 into, what is delta A? 2 into 10 to the power 3 meter square. So, our actual means, here it is given 2 into 10 to the power 3, but to get the actual surface area of a soap bubble, you have to multiply it with more 2, because again I am telling you soap bubble has two surface areas. So, it is 4 into 10 to the power 3 meter square. Okay. So, we have got the area. Next, what is given? How much work will be done in blowing the bubble to twice its surface area? Okay. So, sorry, so it's okay. This 2 into 10 to the power 3 is already given from before. That means 2 is already multiplied over there. Now it's given that the area is becoming twice, the surface area is becoming twice surface area. So, we have multiplied with 2. Okay, so here don't take, because they have already given the surface area, so bubble is already given to you. That means it's already 2 is multiplied from beforehand. So as the surface area is becoming twice, so we will multiply it with 2. Okay, so it is 4 into 10 power 3 meters square. Okay, and what is the tension given over here? So tension is given as not given, so you just pick the value from the values it's given in before. So it's Newton per meter. Okay, you're asked to find out what you asked to find out. Work done. Okay, so work done is nothing but it's tension into delta A. W is equal to T into delta M. Okay, so you know delta A, you know T, put it, solve it and get the answer. Okay, so here student, this is an exceptional case. Exceptional case why? Before we have done the sum of soap bubble, and there we were finding, means they have not given the surface area in any case. So to find the surface area, we were multiplying it by 2. Okay, 2 into surface area. But here they have given the surface area. That means they have already multiplied the value and given you. So just we are multiplying this with 2 because the surface area is becoming twice what it is given. That's why we are multiplying it with 2. Okay. Now, let's move to the next sum. Now, students, sum number 5 is same like sum number 4. So, I would request you to solve the sum just as I have done this previous sums. So, already based on this type of sum. So, sum number 5, you try for yourself. Okay. Now, let me go to sum number 6. Let's do sum number 6. Sum number 5, you do it yourself. Okay. Now, sum number 6 is bit different from this type of sum. Let's see what sum number 6 tells us. A liquid drop of radius 1 millimeter. So let us take the radius as R, which is 1 millimeter. 1 millimeter, as you know, 10 to the power minus 3 meter. Okay. So we have converted into meter, is broken into 1000 equal small drops. How much work will be done? W you have to find out. Okay. And surface tension is given as T is given as 0.07 Newton per meter. Okay, anything? And pi is given as 22/7. Now, let me explain you, student. There is a big drop. Okay, the big drop is 10 to the power minus 3 meters square. Okay, now it is breaking into 1000 small drops. Okay, so let us take the radius of small drops as smaller. Okay, so smaller be the radius of small drops. Radius of small drops. Now students, I told you that the drop, it is basically spherical in shape. Okay, so as it is spherical in shape, so what is the volume of a sphere? 4/3 pi r cube. Okay, so we can write here 4/3 pi r cube. R cube means the bigger drop. Okay, it is getting broken into 1000 small drops. Okay, into 4/3 pi small r cube. Okay, so 4/3 cancels, pi cancels. What we are left with? R cube is equal to 1000 small r cube. Okay, now r cube 1000 I can easily write as 10 to the power cube. Okay, and r cube. So if I remove this r cube on both sides, what will I get? R is equal to 10/r. Okay, so what will be this small r equal to? Small r will be equal to r by 10. Okay, so we have got the bigger radius is given to us, and we have easily got the smaller radius. Okay, you can solve it over here and get the value of r also, because capital R is already given to you. Okay, it's up to you what you do. Okay, so r we have got as capital R by r. You can just put the, let me show you by putting the value 10 to the power by 10. Okay, so you can just put it, solve it, and solve for r, and afterwards also you can put it. Okay, now next, coming to the next portion, it's told how much work will be done. Now here though we have easily found out your this one. We have found out the radius. Now before finding the work done, they have asked to work done. Tension is given. What we have to find out next? The surface area. Okay, so how we'll find the surface area? Let me give you a proof. So from here you're getting the r value, capital R also we know. Now we'll easily find out the surface. So just I'm showing it over here. I'm just rubbing this portion. I'm writing the basic thing over here and rubbing this portion to show you how to find out the surface area. So we have got the relation small r is capital R by 10. Okay, you can put the values or you can keep it like that also. Okay, so we have to find out delta A. Now, how will you find out delta A? Delta A, okay, it is nothing but the 1000, it means it is the surface area of the 1000 drops which are breaking minus the big drop. Okay, so you can easily write it as 1000 into 4 pi r square minus 4 pi capital R square. Okay, so if you take 4 pi common, okay, so 1000 means 10 to the power of 3, you can write it as 4 pi, take it as common. So you are left with r square minus capital R square. Okay, now, so students, you are going to solve it. Put the value 10 cube, 4 pi, 4 into 22 by 7. Put the value of r as r by 10 and r square. Okay, so just put it, solve it, and you'll get the answer. Okay, so here you'll get delta A from here if you solve this portion. Okay, after solving this portion, what you're going to do after this, you have to find out W. So W is equal to your T into delta A. Okay, so from here you are going to find out delta A, and after finding delta A, you just put the value over here, and surface tension is already given over there, and you will get the value of W. Okay, okay, so you will get the value of W. So this was about sum number 6. Okay, so basic concept is here is, student, that a bigger drop is breaking into 1000 small drop. So if you take the bigger drop as capital R and the smaller drop radius as small r, from there we are finding the value of r, small r, which is capital R by 10. After that we are finding the surface area. Okay, so after finding surface area, just put it in the formula, W is equal to T into delta A, and you're getting the work done. Okay, so sum number same is exactly same as sum number 6. So please try to solve it yourself. Okay, now let us move to next sum number 8 also. Okay, sum number 8 is also same as sum number 6. 7 and 8 is similar to sum number 6. So these two sums you're going to practice it. These are important type of sums, so please practice it yourself. Okay, now let us go to sum number 9, which is different from sum number 6. Okay, so let's do sum number 9. Sum number 9, let's see what it is telling. It's telling, calculate the energy released when 1000 small drops, just the opposite of sum number 6. Okay, when 1000 small drops, each of same radius, 10 to the power of minus 7, okay, coalesce to form water of for one large drop. The surface tension of water is 7 into 10 to the power of minus 2. Okay, so let r be the radius of the bigger drop and small r be the radius of the smaller drops. Okay, so what they are telling, that 1000 small drops, they are means joining together to form the bigger drop. Okay, so I can say 1000 into, as we have done in the 6th sum, and I told you that the drops are like spherical in shape, the volume is 4 by 3 pi r cube. So 1000 into 4 by 3 pi r cube, because r is the radius of the smaller drops, is equal to the volume of the bigger drop with the radius capital R cube. Okay, so 4 pi gets cancelled. We are left with 10 to the power of 3 r cube is equal to r cube, or r is equal to 10 r. Okay, so what? So here, see students, what is given? The value of small r is given as 10 to the power of minus 7. R is given as 10 to the power of minus 7. Okay, 10 to the power of minus 7. Okay, so here if you it means you can easily solve for capital R, 10 to the power of minus 7. That means 10 to the power of minus 6. Is it meter? Yes, meter. Okay, so you got the value of small r, you got the value of capital R also. Okay, in that case also, in sum number 6 also, you can solve it there only to get so that the sum gets simplified when you're solving for your surface area, the change of area. Okay, so we have got this. Now what we are going to find out? We are going to find out the surface tension. Before finding that, let us find the change in area. Okay, so delta A is nothing but 1004 pi r square. Okay, 1004 pi r square minus 4 pi r square. Okay, so 1000 into 4 pi r square minus 4 pi, sorry, here I've done a mistake. It should be the bigger minus the means final minus the initial, because in the previous case what was the initial? Initial was the bigger one and final was the smaller one. But here it is the smaller one and the final is the bigger one. So we should start with 4 pi capital R square minus 1000 4 pi R square. Okay, so you can take 4 pi common. So you are left with R square minus 10 to the power of 3 into small r square. Okay, you know capital R, small r, both the values you know. You can put it, solve it and get the answer for delta A. After finding delta A from here, then the sum becomes very simple, because tension T is given as, how much it is given? Let us see, 7 into 10 to the power of minus 2 Newton per meter. Okay, so delta A you are getting, T you are getting, you can easily find out the work done. So W will be equal to T into delta A. Okay, so in these two types of sums, sum number 6 and sum number 9, they are mostly similar. Only the difference is that in case of sum number 6, it was breaking, and in sum number 9, it is joining. Okay, so just you have to find out the both the radius, different type radius, and bring it in the, find out the surface, change of surface area. After finding surface area, just put it in the formula, solve and get the work done. Okay, so this is sum number 9. Okay, now students, sum number 10 is exactly same like same number 9. So I leave it to you to solve it. Okay, so just follow sum number 9 and sum number 10. You can easily do it yourself. Okay, now let us move to sum number 11. Okay, sum number 11, it is a thin wire is bent in the form of a ring, okay, of diameter 3 centimeter. So diameter is given as 3 centimeter. So what will be the radius? 3 by 2 centimeter. Okay, beforehand only I am doing it. So 3 by 2 centimeter means it is 3 by 2 and centimeter we have to convert into meter. That means 10 to the power of minus 2 meter. Let me keep it, or you can solve it also, no problem. Okay, what else is given? The ring is placed horizontally on the surface of a soap solution. Now, soap solution has two surfaces, okay, and then raised up slowly. How much upward force is necessary to break the vertical film formed between the ring and the solution? Okay, so here we have to find. So surface tension is not given. I picked up the surface tension from the values which is given in your book. Okay, so T is given as how much? 0.05 Newton per meter. Okay, you will get the surface tension from the table which is given in the beginning of the numericals. Okay, so surface tension is given. We have got the radius. What we have to find out? We have to find out what is the force? F. Yes. We have to find out F. So F is equal to 2L into T. Okay. Now, here in this question, they have given you the diameter, or we have found out the radius. So, how will you find out the length? We need the length. Okay. And twice the length, because soap solution, as well as there is your vertical film between the ring and the soap solution. So, we have taken 2L, fine. But L is not given to us. R is given to us. So, how will you find out L? L is nothing but the circumference of the wire. Okay, circumference of the thin wire. Okay, so L is 2 pi R. Now, you 2 into 22 by 7 or 3.14, whatever you want, into 10 to the power of minus 2. So, from here, you will get the L. Okay, so you are getting L from here. Now, just put it in the formula. F is equal to 2L into T. So, L you are getting, T is given to you. Okay, just put it in the formula 2L into T and you will get the force. Okay, this is a very easy type of sum. So, next, let us move to sum number 13. Now, students, sum number 12 is exactly same like sum number 11. As I told you in the beginning only, that those sums which are similar type, I have left it up to you to practice, so that you can, so that after seeing the sum, you understand that yes, I have understood this sum. So, I have left the next sum to you. So, please do it, solve it and send it to me. Okay. Now, sum number 13. Let's do sum number 13. What is sum number 13 telling? The air pressure inside a soap bubble. Remember, soap bubble. That means this formula we have to take. Of diameter 3.5 millimeter. So D is given as 3.5 millimeter. So as we do, first we'll convert into meter. That means 3.5 into 10 to the power minus 3 meter. And obviously we don't have any work with diameter. So let's find out the radius. So it is 3.5 by 2 into 10 to the power minus 3 meter. Okay, we have done it. Before doing anything, just convert diameter into radius, because we don't, in any of the formulas which is given over there, we are dealing with radius only. We don't need the diameter. Okay. Now here students, small r, capital R, it's the same thing. I have written capital R. If you want, you can write it capital R also. Don't get confused. There is all these R's over here, small r, capital, are all radius. Okay. Now, it's given is 8 millimeter. Okay, that means H is given as 8 millimeter. 8 millimeter is 8 into 10 to the power minus 3 meter. Okay. Now, what else is given? The air pressure inside a soap bubble of diameter 3.5 millimeters, 8 millimeter of water column. That means height is 8 millimeter. Above the atmospheric pressure. Calculate the surface tension of soap solution. You have to find out the surface tension. Okay. So, T you have to find out. Okay. What else is given? Nothing is given. Now students, obviously for soap solution, pressure P is 4T by R. Okay. So, P is equal to 4T by R. Now, from the quantities given to you, you know R, you know H, nothing else you know. Okay. And what you have to find out? You have to find out the surface tension. Right? You have to find out the surface tension. Right? So, here you can see here students, I have written a formula HR is equal to 2T by rho G. Okay. Or rather in easy form, okay, we can write it is this one means H rho G. Okay. Water column it's given. Okay. We can easily find out. Now to find out the pressure. Okay. So what is the formula of pressure of water? Okay. It is nothing but H rho G, and as it is soap solution, so it is 4T by R. Okay. So H we know, G we know. Now G value you can take it as 9.8. Okay. Meter per second square. Now students, if you take it as 10 also, it's also correct. Only there will be a difference of few decimals, nothing else. You can take it as 9.8, you can take it as 10. Okay. So G is 9.8. Now rho you know, because the density of water is 1000 kg per meter cube. So rho is 1000 kg per meter cube. Okay. So you know H is given as this, rho is given as this, G is given as this, R is also given. This R I am writing it as capital R, otherwise you will get confused. So capital R is also given. So you can easily find out T. So T is nothing but R gets multiplied over here. So it is RH rho G by 4. Okay, you know the value of R, you know the value of H, you know the value of rho, you know the value of G by 4, and it will give you the surface tension T of the soap bubble. Okay, so basically we are using the formula P, or you can see here also this formula basically here it's for the air bubble. Instead of air bubble, if you put 4T, that formula also is coming, and rather in the easy form, you know pressure is nothing but H rho G. In case of water, the pressure P is H rho G. So I have used that formula over here. Instead of pressure, I have written H rho G is 4T by R, 4 into tension by radius, and here I have just solved it and got the formula. Okay, so you can do either way. You can use this formula also, or you can use the pressure formula and find out in terms of tension. Okay. Now, let's move to next sum. So, you get the answer. Okay. Remember the unit will be Newton per meter. Okay. Now, let us move to sum number 14. Okay. Sum number 14. Let's see what is sum number 14. Students, I have gone through the sums, and whichever sum I felt that it's the same type which I am doing with you. Those sums I have one I have done example, and the rest I have left it for you to do. But those who are different type, the sums which are different type, I have done it for you to understand the sum. Okay. So let's do sum number 14. What is sum number 14 telling? What would be the excess pressure above atmosphere inside an air bubble of 0.2 millimeter radius? That means R is given as 0.2 millimeter, which is 0.2 into 10 to the power minus 3 meter. I have just converted it. situated just below the surface of water. The surface tension of water is given as 0.07 Newton per meter. Express the excess pressure in terms of the height of Mercury column. In terms of height of Mercury column. Okay. So that we will do it afterwards. Now read the question, student. What would be the excess pressure of water? It's an air bubble. Air bubble. So I told you this is air bubble. Okay. And this is for your soap bubble. Okay. So as it is air bubble, so pressure P is 2T by R. Okay. It's a very easy sum. So you know the value of T, you know the value of R. Just put it, solve, and you'll get the pressure P. Okay. So you have done one part. Next part, they have told express the excess pressure in terms of height of Mercury column. As you know, students, that whatever the answer you're getting, you will get in pascals. Okay. So to convert into height of Mercury column, what you are going to do, whatever pascal answer you're getting, just multiply with 76 centimeter of Hg or Mercury. Okay. So if you multiply over here, you will get the answer. Okay. 76 centimeter of Hg, you multiply and you will get the answer. Okay. So this was sum number 14. It's a very easy sum. Only the difference is they have asked you to convert into your this one, your height of Mercury. Okay. Now coming to sum number 15. So just you have to remember, in case of air bubble, it is 2T by R, and in case of soap bubble, it is 4T by R. Okay. Next, number 15 sum. Let us see what 15 sum is telling us. Okay. Sum number 15 tells, find the depth, means H, at which an air bubble of radius 0.7 millimeter. Okay. So obviously I will convert it into meter into 10 to the power of -2 meter. Okay. Will remain in equilibrium in water. Given surface tension T is given as how much? 7 into 10 to the power of -2 Newton per meter. Okay. What else is given? G is given as 10 meter per second square. Okay. So again, find the depth at which an air bubble of radius will be equilibrium in water. Okay. So it's a very easy sum. So as it is air bubble, so P is equal to 2T by R. What you asked to find out? H. Before also I told you pressure is nothing but H rho G. Okay. So H rho G is 2T by R. Okay. So what will be, again this R and capital R is the same. So what will be the value of H? So H is nothing but 2T by R rho G. Okay. So see, T is given to you, R is given to you, G is given to you, and rho, obviously density of water is nothing but 1000 kg per meter cube. Okay. So rho is also given to you. Just put these values, solve and get the height. So see, so easy formula. Okay. So next, let us go to sum number 16. Sum number 16 is bit different from this sum. Easy but bit different. Okay. So let's do sum number 16. Sum number 16, it's told there is an air bubble of radius 1 millimeter. So R is given as 1 millimeter, which is 10 to the power of -3 meter. I have converted it. In a liquid of surface tension, T is given as 0.075 Newton per meter. Okay, fine. And density 10 to the power of 3. So rho is given as 10 to the power of 3 kg per meter cube. So here they are given the density. If it is not given also, don't worry. You know the density of water is 1000 kg per meter cube. Okay. The bubble is at a depth of 10 centimeter. That means H is given as 10 centimeter. 10 centimeter is 10 by 100 meters. Okay, which is 0.1 meter. Okay, now done. After that, what else is given? By what amount below the free surface, by what amount is the pressure inside the bubble greater than the atmospheric pressure? Okay, that means they have asked you the pressure inside the bubble. Okay, greater than the atmospheric pressure. That means Pi. So, and G, you can take it as 10 meter per second square, 9.8. That's up to you what you want to take. So, what bubble it is? Air bubble. Air bubble means 2T by R. Okay, so our formula is Pi is equal to PO, or rather you can say P. Okay, P plus the excess pressure. Okay, okay, let me write PO. PO plus P means air bubble, it is 2T by R. Okay, now what is PO? It is nothing but H rho G, the pressure of the water. Okay, so PO, the outside pressure is nothing but the pressure of the water, H rho G plus 2T by R. Okay, so you see here R is already given to you, R is this given, then T is given, rho is given, G is given, H is given, everything is given. Put it in the values, solve, get the answer. Okay, so if you are asked to find the inside pressure, it is nothing but the outside pressure plus the excess pressure. Now if they tell soap solution, it is 4T by R. As they have told air bubble, so we have used 2T by R. And outside pressure is nothing but H rho G. Okay, so this is your sum number 16. Okay, now next coming to, now sum number 17 is exactly same as sum number 16. So I have not done that sum. That sum you will do it yourself as it is similar. Okay, now let's go to sum number 18. Let's see what sum number 18 is telling us. Okay, sum number 18. Sum number 18, it is telling the diameter of a, now it's a capillary rise sum or capillary, very easy sum. So diameter of a capillary tube D is given as 0.4 into 10 to the power of minus 3 meters. Okay, so we have to find out the radius, 0.4 by 2 into 10 to the power of minus 3 meter. Okay, we have found out the radius. It is held vertically in a liquid whose density is rho. That is, rho is given as how much? 0.8 into 10 to the power of 3 kg per meter cube. Okay, and the surface tension T is given as 9.8 into 10 to the power of how much? Minus 2 Newton per meter. Determine the height to which the liquid will rise in the tube. That means H you have to find out. Okay, theta, it is given angle of contact is 0 degree. Theta is already given as 0 degree. Very good for us. Okay, so what they have asked you, you have to find out the height to which the liquid will rise in the tube. Okay, now G you can take it as 9.8 meter per second square. Okay, so what is the formula of capillaries? This one, T is equal to R H rho G by 2 cos 0 degree. Now cos 0 degree is already 1, you know. Okay, so our cos 0 degree, so our formula becomes R H rho G by 2 because cos 0 degree is 1. Okay, what do you find out? H. So what will your formula become? H will be 2T by R rho G. Okay, 2T, 2 into tension, surface tension, by R rho G. So tension is given to you, see, rho R is given to you, rho is given to you, G is also given to you. Put the value, solve, and you'll get the height. So it's just direct application of formula, very easy. Okay, now let's move to sum number 20 quickly. Sum number 9 is exactly same like sum number 18. So I have not done sum number 19. Sum number 19 you will do it yourself after you understand sum number 18. Okay, now let's do sum number 20. So you see here similar sums are given and I have left those sums for you to practice to see how much you have understood. Okay, sum number 20. Water rises in capillary tube to a height of 5 centimeter. So H is given as 5 centimeter. Okay, so let me convert into meter. That means 5 by 100 meter. Okay, which is 0.05 meter. Right? If the surface tension of water T is given as 9.8 into 10 to the power of minus 2 Newton per meter. Then find out the diameter of the capillary tube. Okay, you are asked to find out the diameter D. You have to find out the capillary tube. Okay, so obviously, so here you have, so we'll be using this formula because theta is not mentioned over here. So basically we are going to use this formula over here. Okay, so what is the formula over here? So HR is equal to 2T by rho G, and you know diameter is nothing but 2 into radius. Okay, if you get the radius, you will easily get the diameter. So what will be R equal to? R will be equal to 2T by rho GH. Okay, so what it is told? Water. Since water is given to you students, so you are going to take rho as 10 to the power 3 kg per meter cube. Okay, and G you take as 9.8 meter per second square. Okay, so you see here, you know the tension, you know rho, you know G, you know H. Put the values, solve, and you are getting the radius. After you get the radius from here, just put the value over here, just multiply it with 2 and you will get the diameter. Okay, you get radius, multiply it with 2 and you get the diameter. Okay, so you see the sums are so easy if you know the formula. Okay, now let us go to the next sum. Sum number 21 and 22 are same like sum number 20. Okay, based on capillary rise. So I have not done sum number 21 and 22. Please do it yourself, practice it yourself. Okay, now let me go to sum number 23. Okay, please practice it yourself, and still if you have problem, you can contact with me. Okay, sum number 23. Hope you will not have problem because both the sums are based on capillary rise. Just write down the quantities, formulas, so I have already written, so you will do it. Okay, sum number 23, let's do the sum. Water rises in a glass capillary up to a height of 9 centimeter. That means H is given as 9 centimeter, which is 9 by 100 meter, which is 0.09 meter. Okay, so whenever you get a unit, please first convert to a proper unit. Now, what else is given? While mercury falls down by 3.4 centimeter in the same capillary, means another height is given to you. So let H dash be 3.4 centimeter. Obviously, you can convert into meter. 3.4 by 100 meter, which is 0.034 meter, or you can also write it as 3.4 into 10 to the power minus 2 meter. So whichever you are comfortable in, you can write it similarly. Okay, now what else is given? Or you can take H and H1, 1, H2 also, or H or H dash also, no problem. Now what they have given? Assume angle of contact for water and glass, water glass and mercury glass is 0 degree and 35 degree. That means theta 1, suppose theta and theta dash I am taking, one is 0 degree, one is 135 degree. Okay. Determine the ratio of surface tension of mercury and water. Okay, you are asked to find out the surface tension of mercury and water. Okay, surface tension T you have to find out. Now here students, since glass and mercury, okay, we are using two types. One is water rises in glass capillary and mercury falls down in the same capillary. Means the capillary here is the same in both the cases. Okay, so here what is the difference over here? Here the difference is the density given over here. Density. No, density is not given over here. I think density is given in your the table which is given over there. There the tension is. I think density is given over there. Yes, density is not given over here. So here students, basically, so let us find H first. So what is the formula of H from this formula? Because theta is included over here, so H is nothing but it will be 2T cos theta by R rho G. Okay, 2, or basically we can say it is T R rho G. Okay, let it be R rho G only. Afterwards I will change it. Okay, radius. Now what will be H dash equal to? H dash will be equal to 2T dash, because we are taking H dash, so I will take the tension because tension is different in both the cases. Okay, one is water, one is mercury. Okay, so 2T dash cos theta by R rho dash G, because density is obviously different, so we'll be using different densities. Okay, so here you see here students, we have got this to formula. 1 H is 2T cos theta by R rho G, and H dash is 2T dash cos theta dash by R rho dash G. Now here students, we have to compare what? We have to determine the ratio of the surface tensions. So what will be T equal to? It will be equal to your, if this is H, so T will be equal to H R rho G by 2 cos theta. Okay, and this T dash will be equal to your H dash R rho G rho dash G by 2 cos theta dash. Okay, this is the T and T dash we are getting from the formula. Okay, now we will find out the ratio between them. Okay, so what will be the ratio between them? So let's see what is the ratio between them coming out as. So okay, I'm doing it over here only. So what will be T by T dash equal to? So T by T dash, let's solve it. So H R rho G by 2 cos theta, okay, into, now this term as it is down, it will just get means rolled over and it will become theta dash by H dash R rho dash G. Okay, G gets cancelled, R gets cancelled. What we are left with? We are left with H rho cos theta by H dash rho dash cos theta. 2 gets cancelled. So we are left with H rho cos theta by H dash rho dash cos theta only. Okay, it is cos theta dash by cos theta. Okay, so you see here, you know the value of H, you know the value of H dash. Now, rho is the density of water and rho dash is the density of mercury. Density of water, which is rho is equal to 1. Okay, or if you convert it into kg, it will be 1000. Okay, or you can keep it in centimeter. So if you take it as centimeter, okay, so you no need of converting this also, and if you keep it in meter, you need to convert kg per meter cube, and of mercury is 13.6 into 10 to the power of minus 3 kg per meter cube. Okay, so this is water and mercury. So you know rho dash. Okay, rho dash, put the value. Okay, solve and you will get the answer. Okay, so this is your sum about. So here you are bringing the tension. First you are converting the tension in the form of means the values given. Okay, so the radius is the same in both the cases and acceleration due to gravity is same. But rest of the quantities, H dash is not same, rho dash is not same, and cos theta is obviously different. One is 0 degree, one is 135 degree. Okay, so I've written all the values, theta dash, H dash, rho dash. Just put it in this formula, H rho cos theta dash by H dash rho dash cos theta. Okay, just put the values, solve and get the answer. Okay, now students, you can also do it if you want. You can just keep it in centimeter also, because we obviously here it's not compulsory to convert it into meter, so you can keep it in centimeter also. And if you convert it to centimeter, these values will also change. Okay, it will be easy for you. So H is 9 centimeter, it will be 1 gram per centimeter cube, and it will be 13.6 gram per centimeter cube. Okay, theta obviously it doesn't depend on the CGS or SI unit. Okay, so you can do the sum in both ways. You can convert into SI unit also. If you want, you can convert into CGS unit also, because here we have got to find the ratio. Okay, we don't have to find out, we're not finding a quantity, we are finding the ratio. So it's up to you, whichever you convert. Okay, so H is 9 centimeter, H dash is 3.4 centimeter, rho is 1, rho dash is 13.6, cos theta dash is 135, cos theta is 0. Just put those values. You will see cos theta dash 135 value is given as how much it is given. It is given something like minus 0.71. That is also given to you. And if it's not given also, what a problem. You have the scientific calculator. You can easily get the value from there. Okay. So this is sum number 23. We are just putting this capillary formula for one for water, one for mercury, and finding the ratio between them. Okay, with the different angles. So now sum number, after this let us go to sum number 24, because 24 is also different type of sum. So I would also do sum number 24. Okay, so sum number 24, it's given water rises up to 2 centimeter in a capillary tube of length 20 centimeter. Okay, so H is given as 2 centimeter. Okay, now I'm not converting it. If required, I'll convert it afterwards, because this type of sums basically means theta is given over here, so you need not convert, you can keep it as it is. Okay, so it is 2 centimeter capillary tube of length 20 centimeter. held vertically means perpendicularly. If the capillary is bent by 30 degree, means theta is given as 30 degree. Okay. From the vertical position, find the length of liquid rising in it. That means you have to find out H dash. Okay, it's a very easy sum. You have to find out H dash. Okay, so H dash is nothing but H by cos theta. Okay, that means H 2 centimeter by cos 30 degree. As I was telling you, it's not compulsory to convert into SI unit. Okay, you can keep it in CGS unit also. You solve, you'll get the answer also. Okay, so this is your easiest sum, which is given H dash is equal to H by cos theta. Okay, now coming to sum number 25. Okay, before I start the sum, let me tell you sum number 26 is exactly same like sum number 25. So please understand sum number 25 very well. You can easily do sum number 26. Sum number 25 is also very easy based on the capillary action. Okay, so let's do sum number 25. It's given a capillary tube of radius 0.4 millimeter. So R is given as 0.4 millimeter. Okay, so here we will be converting. So let us convert into meter, 10 to the power minus 3 meter. Remember students, if theta, you see there is only one value given, none other of the value is given and theta is given, you can keep it as it is in CGS or SI, whatever you want. But when lots of values are given, please convert into proper unit, either all in CGS or all in SI. Otherwise your sum will be wrong. Okay, so R is given as 0.4 into 10 to the power minus 3 millimeter. Vertical in water, find up to what height H you have to find out will rise in the capillary if the capillary is inclined at an angle of 60 degree with the vertical. Okay, what vertical? That means theta is given as 60 degree. Okay, 60 degree with the vertical. How much length of the capillary is occupied by water? Okay, capillary occupied by water, surface tension T is given as how much? 7 into 10 to the power minus 2 Newton per meter. Okay, now G you take as 9.8 meter per second square. Okay, and rho as it is water. Yes, water. So it will be 10 to the power 3 kg per meter cube. Okay, so first we have to find out H. And then we have to find out H dash also. Okay, there are two heights you have to find out. It's given, find out up to what height the water will rise in the capillary. If the capillary is inclined at an angle of 60 degree with the vertical, how much length of the capillary is occupied? That means two heights we have to find out. So let's find H first. So obviously as you can see, we can just put it in this formula. So what will H come out as? It will be 2t cos theta. Now one theta is given. So this theta is when it is inclined. Okay. So what is the first theta we have to put? What theta you have to put? It is kept vertical. So kept vertical means theta is 0 degree. Okay. So in the first case theta is 0 degree because it is kept vertical. Okay. So cos theta is cos 0 degree by this one by R rho G. Okay. You solve it and you get the value of H from here. So see, R is given, rho is given, G is given, T is also given. Okay, you can easily put it and cos 0 degree is nothing but 1. Okay, so you just put it, solve and you'll get the answer of H. Now, how will you find H dash? Very easy. Just now I told you H dash is nothing but H by cos theta. Now here theta is 60 degree because it has inclined to 60 degree. Okay, so it is H by cos 60 degree. So from here you are getting H, put this H over here and cos 60 degree value put it. Okay, solve it and you'll get H dash. Okay, so sum number 26 as I have already told you is exactly similar like sum number 25. Okay, hope students you understood the surface tension sums. So please do all these sums and I'll be setting the assignment for you. Please do all the sums, complete all the sums starting from 1 to 26. The sums which I have done in the video as well as the sums which I have left for you to work. Please solve all these sums and send it for checking. Okay, hope you have understood this video. Okay, take care students. Bye.